अस्सलाम वालेकुम स्टूडेंट, कैसे हैं आप सब? होप ऑल यू आर फाइन। अच्छा, आज जो हम टॉपिक डिस्कस करेंगे वो है आपके पास एसी सर्किट। व्हाट चैप्टर एसी सर्किट एंड टॉपिक इज व्हाट इज अ कैपेसिटर. Capacitor is basically is used for store charge and energy temporarily. So here we write that a capacitor is a device. A capacitor is a device used to store charge and energy temporarily. Okay, now we discuss some points that is related to the capacitor. Capacitor has two conducting plates. It has two conducting plates. Conducting plates. Between them is an insulator like air, water, paper, etc. That is, here we write that between them is an insulator like air, paper, etc. Okay, third point that we discussed, that when connected in a battery or voltage source, positive charge gather on one plate and negative charge gather on the other plate. So here we write that Rehan Ali. Rehan Ali, Assalamu alaikum. Welcome to my class. Thank you for your nice comment. Thank you all of you who is watching my video. Thanks for your time. Okay, what we discussed that in one plate of the capacitor is positive charge and other is the negative charge. When connected to a battery, connected to a battery or voltage source, positive charge gather on one plate, gather on one plate, and negative charge gather on the other plate, and negative charge gather on other plate. Okay, fourth point, that is the capacitor is also used to store and release energy whenever they required. When we require to store energy, we use capacitor. Whenever we require that the capacitor give us the energy, so we also use for release energy. So here we write that it can store and release energy whenever they require. Okay हो गया. So we discuss here what is a capacitor. Capacitor is basically a device to store charge and energy temporarily. It has two conducting plates. Between them we use an like air and paper etc. When connected to a battery, positive charge gather on one plate and negative charge gather on the other plate. So it also can use for store and release energy whenever they require. So our next topic now we discuss that capacitor is connected to the AC source. What happens when the capacitor is connected to an AC supply? In AC voltage, it continuously changing its direction. Okay, now here we draw the circuit diagram. In the circuit diagram, we take the capacitor and connect it to the AC source. So here we take the AC source capacitor, that is we denoted by capital C, and here we supply the alternating source, that is voltage, and here is the current is flowing in the circuit. So here we write that when we connect what happened? Connect a capacitor to AC source, so voltage is continuously changing its direction, changing its direction. Okay, what happened inside the capacitor? Inside the capacitor, the capacitor charge when voltage increase in one direction. When we apply to the voltage, when the capacitor is applied by the voltage source, so the capacitor is store the charge, voltage is increase in one direction. So here we write that the capacitor starting to charge, capacitor charge when voltage is increase, when voltage increase in one direction, Okay, here we discuss that the voltage is continuously changing its direction. When the voltage is applied in one direction, the capacitor is charged. When the voltage is reversed, the capacitor discharge and the chain and the charge in opposite direction. How it reverse its direction? If when we apply the voltage source, it gathers the positive charge on one plate and negative charge on the other plate. When the voltage source reverse its direction, so when first when they store the positive charge, now it store the negative charge, another plate is store the positive charge. So voltage is also when the voltage is reversed, so capacitor charge start discharging. How it is start the discharging? Let's suppose when we connect with the AC voltage source, first store the positive charge on one plate and negative charge on the other plate. So when the voltage is reverse its direction, so negative charge that is stored on the negative plate, it start to moving toward the positive plate. So here it become the positive charge and in this plate become the negative charge. So it continuously changing its direction. So capacitor is charged or discharged when the voltage is reverse its direction. So here we write that when voltage reverse when voltage reverse, the capacitor discharge and then charge in opposite direction. So in every cycle of alternating current, the capacitor keep charging and discharging. So basically, we discussed the point that is the when we apply it to the alternating source, capacitor is keep changing its direction. It keep charging and discharging when it connected to an alternating source. So here we write that. So in every cycle of so in every cycle of alternating current, the capacitor keep charging and discharging. The capacitor keep charging and discharging. So here we discuss that the what happened to the capacitor when it applied to an alternating current source. When it applied to the alternating current source, it keeps changing its direction. So when it keeps changing its direction, so the capacitor keep charging and discharging. Okay, now we discuss the current and voltage relation in the capacitor when we apply to the alternating voltage source. So here we write that uh, okay. Now we discuss that in a capacitor, current lead the voltage by 90 degree. When we connect the capacitor to alternating voltage source, so the current lead the voltage by 90 degree in a capacitor. Current leads the voltage by 90 degree. So here we take the example so you easily understand that what happened inside the capacitor. So here we discuss the example. By example you easily understand that what happened inside the capacitor when it is applied to the AC voltage source. So here we take the bucket. Think of a bucket like a capacitor. This is the bucket and we fill it with the water. The water that is come into the bucket, that is we suppose that is the current I. When the water is filled in the bucket, the level of the water is shows the level of the voltage in the capacitor. So here the flowing water into the bucket, that is the current, and the level of water in the bucket, that is shows the voltage. So here we write that think of a capacitor, think of a capacitor like a bucket, like a bucket collecting water. Okay, now we discuss that what is the voltage in the bucket. Voltage is the water level inside the bucket. The water level inside the bucket. And what is the current? The flow of water going into the bucket, that is shows the current. So here we understand the capacitor by take an example of the bucket that is filled with water. So water flow into the bucket, that is the current, and water level inside the bucket, that is shows the voltage. So here is the basically we क्या होगा, मैं जो आपको बताना चाह रही हूँ वो ये है कि आपके पास एट स्टार्ट so what I basically discussed that at start empty bucket जब आपके पास बकेट जो है वो एम्प्टी होगी उस टाइम आपके पास जो वोल्टेज होगा वो क्या होगा, ज़ीरो होगा. ओके हो गया. वाटर लेवल स्लोली इंक्रीज so voltage increase. At start bucket empty. At start the capacitor is empty so voltage is zero. So when the time is increase, so water level is also increase slowly. So here we write that water level water level slowly increase. So voltage is increase. Okay हो गया. So this is what we want to discuss that. So flow of water, the current is maximum. So water is flowing continuously. So current is maximum. So here we write that. So flow of water, current current is maximum. Okay, now we discuss that if the water level inside the bucket rise slowly, the voltage take time to build up. So what is they learned from this example said that the water level inside the bucket rise slowly, so voltage take time to build up. That is why in the capacitor current always lead the voltage because current is continuously flowing. So current is maximum, but voltage take time to build up. So current is lead the voltage. So here we write that. Okay, here we write that the water level, the क्या the water level inside the bucket takes take time to build. So voltage rise slowly. When the voltage is rise slowly, so here we write that. That's why in capacitor that's why in capacitor current I always lead voltage V वैसे current I always lead voltage. So this means current reached maximum value before the voltage does. So here we write that this means current reach its maximum value before the voltage does. Okay हो गया. So this is we discussed that the current and voltage relation in the capacitor, that is the voltage is lag behind the current and current is always lead the voltage. So next topic it is the capacitive reactance. Now we discuss the capacitive reactance. Okay, that is the very interesting topic in capacitive reactance. Capacitive reactance is the basically the opposition offered by a capacitor. So here we write that who is texting? Nothing. That all is. Capacitive reactance. A capacitor reactor is the opposition offered by a capacitor to the flow of alternating current. Capacitive reactance is the opposition offered by a capacitor to the flow of alternating current AC. So here we write that capacitive reactance, that formula is Xc is equal to 1 over omega C, omega that is equal to 1 over 2 pi f C. So here we write that reactance is similar to the resistance, but it happens because of the capacitor, not a resistance. So here we write that reactance is similar to resistance, but it happens because of the capacitor, not a resistance. So in this formula we learned that the higher frequency mean smaller reactance. When the reactance or opposition is offered by the capacitor is small, so current is flowing maximum. So here we write that higher frequency means smaller reactance. So it means that the opposition offered by a capacitor is small. When the opposition offered by a capacitor is small, so more current is flowing. So current is more. Okay, next case we discuss that when the frequency is low, when we alternating source that is applied to the capacitor, that is changing direction slowly, so its frequency is low. When the frequency is low, so it offer higher reactance or higher resistance to the current flow in the circuit. So it offer the larger reactance, so less current flow into the circuit. So here we write that low frequency mean larger reactance or larger resistance, larger larger reactance means less current flow in the circuit. Okay, last point we discussed that in the DC circuit that the frequency is not changing, that the AC signal that is flowing smoothly, that is not change the direction. So frequency is 0. So here we write that for DC frequency is 0. When frequency is 0, so 1 over 0 become infinity. So reactance become Xc, that is shows the reactance. Xc become infinite. Infinite means that is shows the flow resistance to the flow of the current, that is the infinite. So no current is flow. No current is flow because the reactance is infinite. That is, we discussed the capacitive reactance. Now we discuss it separately. What happens when the higher frequency to the fast AC signal and low frequency mean the low AC signal. When the fast AC signal is applied to the capacitor, what happened inside the capacitor? And when the low AC signal is applied to the capacitor, and what happened inside the capacitor? So here we write that, यार कोई तो आ जाओ, कोई दूसरा तरीका ही ढूंढना पड़ेगा. एनीवेज कौन सा यूज करूं? Okay, now we apply the higher frequency to the capacitor. So voltage change very quickly. The voltage changes very quickly. When the voltage change very quickly, the capacitor does not get time to fully charge. So here we write that the capacitor does not get time to fully charge. What it means, when we apply the AC source to the capacitor, that is AC signal is very fast. So capacitor is change it, so AC source change direction very quickly. So capacitor that is not get enough time to become fully charged. When the capacitor is become fully charged, it does not allow to the more current flow into the circuit, so it block the current. So uh, fast AC signal that is very fast, that is no give to time to the capacitor to become fully charged. So capacitor keep charging and discharging rapidly. So here we write that it does not get time to fully charge because it keep charging and discharging rapidly. So it does not block the current. when this capacitor block the current, when this become fully charged. So in the fast AC signal, it does not get time to fully charge. So it does not block the current. So it does not block current when the current is does not block. So it means that the small reactance, it offer low reactance to the current, so more current flow into the circuit when the fast AC signal applied to the capacitor. That is, I want to discuss that when the fast AC source is applied to the capacitor, that is the higher frequency. So where capacitor is does not get time to fully charge, so it keep charging and discharging. So when it keep charging and discharging, it does not block the current. So smaller reactance, more current flow. So now we discuss that the next topic, that is the when we apply to the AC source to the capacitor, when the slow AC signal, so lower frequency. So here we write that mm, okay. Now we discuss the next topic, that is the lower frequency, low AC signal applied to the capacitor. So here we write that when the low frequency AC signal applied to the capacitor, so the voltage change slowly across the capacitor. The voltage charge slowly. So the voltage charge slowly. The capacitor get enough time. The capacitor get enough time to almost full when the voltage change slowly. So capacitor get enough time to almost full once it charge it block further current until the cycle is reversed. So when the voltage is slowly, capacitor is get enough time to become full. So when it is charged, so it block the further current to flow it. Once it charge, it block further current until the cycle reverse. So it oppose current more strongly. So when it block the current, so here we write that when the low AC signal is applied to the capacitor, so capacitor that is oppose current, so it oppose current more strongly. When it is oppose current more slowly, so large reactance offered to the current. When it offer the large reactance to the current, so it strongly oppose the current. When it strongly oppose the current, so it means that less current flow into the circuit, less current flow into the circuit when the slow AC signal is applied to the capacitor. When the slow AC signal is applied to the capacitor, the voltage charge slowly. The capacitor get enough time to almost full. Once it charge, it block further current until the cycle is reversed. If in the slowly voltage source, the voltage take time to reverse its cycle. So when it take time to reverse its cycle, that time the capacitor is almost full. When the capacitor is full, it does not allow to the more current flow into the circuit. So it opposes the current more slowly. When it opposes the current more slowly, large reactance is offered to the current. So less current is flow into the circuit. Now we discuss the graph for AC through a capacitor. Uh, Okay, when alternating current source is applied to a capacitor, the alternating current always lead the alternating voltage by phase angle of 90 degree. So, when alternating current source connected to a connected to a capacitor, the alternating current the alternating current I lead the voltage by phase angle 90 degree or pi by 2. So here we draw the graph so that you easily understand that. Here we draw the graph of the voltage and current. So we know that when the current is maximum, so voltage is 0. Here voltage start from the 0, it become maximum, then again 0, then it become maximum negative side. So it again becomes 0, then it maximum. So this is the voltage of the this is the graph of the voltage. Okay, now we know that in the capacitor case, the current always lead the voltage by angle of 90 degree. So here we draw the graph of the current. This is the graph of the current that is always lead the voltage by 90 degree. So if here it is the angle of 90 degree, so it shows that the current is maximum and voltage is current is 0. What happened here? So here is this, we understand that here the voltage is 0 and current is, that is the 90 degree. So phase angle is 90 degree, phase difference between them is 90 degree. That is the graph for AC through a capacitor. Okay, now we discuss the phasor diagram when the alternating current source is applied to a capacitor. Okay, we know that in AC through capacitor, AC AC through capacitor, voltage V is lagging behind current by 90 degree. When the voltage is lagging behind the current by 90 degree, so its phasor diagram is, here we, in the horizontal axis we take the voltage and vertical axis we take the current. So current that is always lead the voltage by 90 degree, that is the phasor diagram. So here the horizontal line that represent voltage, and current phasor, it will be ahead of voltage by 90 degree. So here we write that current phasor current phasor it will be ahead of voltage by 90 degree. So here we discuss the phasor diagram. When we apply the AC through a capacitor, this voltage is always lagging behind the current by 90 degree. Horizontal line that represent the voltage, and current phasor that it always lead the voltage by 90 degree. So here we discuss that the AC through a capacitor, and we discuss it the different topic. Okay, now we discuss the average power when the AC source is applied to a capacitor. So it is similar to the average power in case of the inductor. Inductor, that is power is consumed is 0. So in the capacitor case, average power that is consumed is also 0. So Next topic is our average power when is AC current is applied to the capacitor. Okay, now we discuss the average power. When AC source is connected to a capacitor, the alternating current heat the alternating voltage by 90 degree. So when AC source is applied to a capacitor, the average power is consumed by the capacitor is 0. Why the average power is 0? We discuss it here. So first we write that uh, when alternating current source applied to a capacitor applied to a capacitor, the average power consumed is 0. Consume is 0. Okay हो गया. Okay, what actually happened? During one half cycle, the capacitor store energy in the electric field. In the next half cycle, it give energy back to the source. So average power is 0. It does not use any or use or consume energy. So average power is 0. During one half cycle, during one half cycle, the capacitor store energy stores energy in the electric field. During the next half cycle, during the next half cycle, it gives energy, it gives energy back to the source. So average power is 0. So average power is 0. So this means capacitor does not consume any energy or any power from the source. So here we write that. So this means A capacitor does not consume energy or any power or any power from the source. Okay हो गया. So this is we discuss the average power, that the average power is consumed by the capacitor is 0, because in one half cycle it store energy in the electric field, in next half cycle it give back energy to the source. So average power is 0. So this means a capacitor does not consume energy or any power from the source when it AC source is applied to a capacitor. So next we discuss the comparison between resistance and reactance. That is our next topic. Today we discuss the topic that is about the capacitor. In next class we also discuss the comparison between resistance and reactance, and also we discuss the what is the active power and what is the reactive power. When we use the term active power and when we use the term that is the reactive power, so we discuss in the next class. So today we discuss it this.